Hey guys, this is chapter 5, lesson 7, and this is all about the integration of inverse trig, all the arc stuff. So what we're going to do, and I'm going to show you the 3 different versions of the arc trig stuff, and then we're going to do practice problems. So let's move this down. Okay. So the first version is when the integral looks like this. Integral of du over radical a squared minus u squared. This will always equal arc sine u over a plus c. Okay? So that's the first one I was going to say. And the second one is du over a squared plus u squared. No radical, no minus. This one is 1 over a arc tangent u over a plus c. Remember, the c's are important because, as far as we know, these are not definite integrals, so don't forget your c's. Integral of du over u radical u squared minus a squared. This is the last one, equals 1 over a arc secant of absolute value of u over a plus c. This one's different because it has an absolute value. Arc sine doesn't have 1 over a, and arctangent has all the regular stuff. So that's how you can remember what they end up to be. Okay, so now let's do some practice problems. Let's move this out of here. Okay, so the first practice problem I have is going to look like this. It's the integral of 3 over radical 1 minus 4x squared. Now, if I'm going to set this to look like one of the arc trig functions, it's going to look like the arc sine one, which is du over radical a squared minus u squared. So a squared equals 1, so a is 1. U squared equals 4x squared, so u is 2x. And du is 2. So what we can do is, because we have to divide by 1/2, we're going to have a 2 right here. It's going to be 2 dx, actually. So we have to divide by 2 on the outside, and we have to take this 3 out of here, because it's going to be 1. Oh, sorry, did I say d? Yeah, no, yeah, that's right. So we're going to take that 3 out, so it's 1 on top, because we want it to be easier to do. So it's going to be 3 over 2 on the outside, because we divide by 2. Integral of 1 over radical, or this is actually going to be du, radical 1 minus 4x squared. So this is, since this looks like arc sine, we're going to do arc sine, let's not forget the 3 over 2, arc sine u over a, which is 2x over 1 plus c. And that is your answer for this problem. Okay, let's do another problem that will use a different arc trig function. Okay, so let's take the function, the integral of 1 over 3 plus x minus 2 squared. So if I was to match this one up with an arc trig function, it would be most likely with the arc tangent, which is du over a squared plus u squared. So if it's supposed to be this one, you take a squared equals 3, so a equals rad 3, u squared equals x minus 2 squared, so u is x minus 2, and du equals 1 dx. So it makes it a little easy on us. It's going to be du over a squared plus u squared. Easy. So now you take 1 over a, so it's 1 over rad 3, arc tangent, u is x minus 2 over rad 3, because that's a, plus c. But then we have to rationalize all of this. So what we do is 1 over rad 3 becomes rad 3 over 3, because you multiply top and bottom by rad 3, arc tangent, rad 3 x minus 2, because you're rationalizing again, over 3 plus c. So this is your final answer. Rationalize and all. Okay? Let's do another one, another normal-ish one, with arc secant at the end of it. So let's see, which one should I do? Okay, so we can do this problem right here, which is the integral of 1 over x minus 1 times radical x squared minus, oops, that's supposed to be minus, 2x dx. Okay, so this one looks mostly like a arc secant, but the thing under the radical does not look right. So what we have to do is you complete the square under the radical, and if you do that, you're going to get radical x squared minus 2x plus 1 minus 1, okay, and that would make it radical x minus 1 squared minus 1. So now we have something that works. So this part right here is going to be u squared. It's going to be a. This part is u. So now we have everything set up for us. U squared equals x minus 1 squared. U equals x minus 1. A squared equals 1. That's a, sorry. So a also equals 1. And du equals dx. Cuts out our work for us. So what we can do, I'm going to move this down so I have a little more room to write the answer down, is you have 1 over a, which is 1 over 1, so it's 1, arc secant, now absolute value of u over a, which is 1, so it's going to be absolute value of x minus 1, plus c. There's your answer for that problem. Don't forget this absolute value right here, because if you don't put the absolute value, the answer is wrong. And yeah, and since 1 over a, there would be a 1 over 1 over here, but that's just 1, so that's nothing. So that's that problem. Let's just do 1 or 2 more, just to get the complete feel of it. Let's do a problem that looks like this. Okay, this one is going to be definite integral from -2 to 2. Okay, you have 1 over x squared plus 4x plus 13. Now this one looks nothing like any of them, but what you can do is you can complete the square for this function down here, and you get this. You get 1 over x squared plus 4x, and you need a 4 up here, so you get 4 plus 13 plus minus 4 on the outside. Okay, so then what you're going to get is 1 over x minus 2, x plus 2 squared plus 9. Okay, now what you would get here is an arctangent looking thing, because if this is a and this is u, it's a squared plus u squared. So a is 3, u equals x plus 2, and let's do the arctangent. 1 over 3 arc tangent x plus 2, which is u, over a, which is 3, plus c. But this is a definite integral, so what we're going to do, since it's negative 2 to 2, is just plug in the numbers. So 1 over 3 arc tangent of 0 over 3 minus 1 over 3 arc tangent of 4 over 3. Well, we know this one's pi over 4 because this is 0, so pi over 4 times 1 over 3 is pi over 12 minus, now this is 4 over 3, which is a 3, 4, 5 triangle, and what you get is something that looks kind of like this. So if you do the arctan fourths on your calculator, you can get pi over 9.9-ish when you multiply by 1/3. And after you simplify that, that's your answer, and you're good. Okay. Let's do another one more problem. Okay. So we can do, okay, let's do this problem. Integral of x over radical 9 plus 8x squared minus x to the 4th. Okay, so for this one, it doesn't really look like anything we've done yet. So what we can try to do is complete the square of this part right here. That one and that one. So what you can do is you'll get radical 9 plus 8, let's put it in order of degree, x to the 4th plus 8x squared, and when you complete the square, you're going to add 16, and then add 16 on the outside. And subtract 16 on the outside. Okay? So then what you get is you're going to get radical negative x squared minus, x squared minus 4 squared minus 7. Okay? So then if you do this could look like an u squared minus a squared, or a squared minus u squared, sorry. This could be flipped to make it negative 7. Or not negative, this should be positive. What am I doing? It's plus 7, this is negative. So what you get is 1 over radical 7 minus x squared minus 4 squared, and that a equals radical 7 and u equals x squared minus 4 du equals 2x dx. Sorry, this is x, not that. So all you have to do is divide by 1/2. You get 1/2 on the outside. Integral of du over radical a squared minus u squared, which looks like our sine, arc sine. So what you do is you get 1/2 arc sine of u over a, which is u is x squared minus 4, and a is radical 7, plus c. And if you rationalize, it's going to be 1/2 arc sine radical 7 x squared minus 4 over 7 plus c. And there is your answer. Okay, that's it for that video. That was all the videos I had to do, so I'll see you later. Okay.